Hello, everybody. This is What's Up with Giancarlo. Alrighty, hey, I'm Mr. Giancarlo. So let's get into this lesson. We're at topic 2, lesson 2 in the Savas book, okay? Describe proportional relationships, constant of proportionality. I can use the constant of proportionality in an equation to represent a proportional relationship. Ooh, cool beans, okay? Let's get going. Okay, so example 1. Write an equation to represent a proportional relationship. A sponge is an example of a filter feeder. It takes in food by filtering water through its body. The sponge maintains a constant flow of water through its body. What is an equation that represents the proportional relationship between the time and the amount of water filtered? So water out, water in, water out, water in. Okay, class. So, so we are comparing liters to water. To blah, blah, blah. Not to water. Duh. That's a silly mistake. Liters to hours. That is what my ratio will be, okay? So we have 8 liters in 10 hours, and we have 12 liters in 15 hours, okay? If we simplify those down, I divide the top and the bottom by 2, the greatest common factor, and I get 4/5, or 4 to 5, sorry. And then the greatest common factor would be 3. I divide them both by 3, and I get 4/5. They are equivalent ratios. Therefore, it is a proportional relationship. So we will find out what the constant of proportionality is. This is the same example. The constant of proportionality is the constant multiple that relates proportional quantities x and y. It is the value of the ratio y over x and is represented by k. Make a table to find the constant of proportionality. Okay, class, I can read that to you and you can listen and get it or whatever, but writing it down is really important because that's like a muscle memory and then it sticks in your brain more. So everybody write this down. Constant of proportionality equals K. Okay? And K equals y over x. That's how you find out what K is. So when you get this table, you look at this row, I'm like, okay, I need to find out what K is. Let's work it out. Y equals 8, and then x equals 10. So it's 8 over 10. Boom. We simplify it to 4/5, or they just do it as a decimal and they get it as 0.8. So now I see it, and then I do it again. 12 over 15 will end up equaling 0.8. So in this example, K, don't know what I was going to write there. K equals 0.8. So now they're going to show us how to write an equation that represents a proportional relationship. So if you have K equals YX, you can use an equation in the form Y equals KX to represent any proportional relationship. So Y equals KX means that we're going to find out what our K is. We don't know what the Y is, but they will give us an X that we can multiply by the K. So when there's no sign in between them, that means multiply. So I will do K times X to find out what my Y is so I can plug it in. All right? Hopefully everybody's written everything down. Everybody understands what we're talking about. Cool, cool, cool. Let's get it going. We have example 1, try it, okay? I'm going to ask you to pause right now so you guys can work it out on yourself. Work it out yourself. There it is. Everybody makes mistakes. All right. Okay, I'm glad you paused it. Let's work this out together now. Maria made 2 batches of fruit punch. The equation y equals 1.6x represents the relationship between the amount of apple juice x and the amount of grape juice y in the fruit punch. Complete the table that shows this relationship and verify the constant proportionality. Okay, first things first. They give us the equation. Y equals 1.6x. Class, if you remember, we just went over it. Y equals kx. Therefore, we have y, we have x. We know that the constant of proportionality equals k, so the k would be 1.6. So the constant of proportionality is 1.6. Okay? And now, to find out what y is, I'm doing 1.6 times x. My x is 5 for one of them. So we do y equals 1.6 times 5, and that'll be y equals 8. So I get 8 here. And then I have y equals 1.6, and then it's a 10 times 10. And we get y equals 16. The 0 will just move the decimal over to the right once. So you get 16. Now for these boxes, they're asking me to write y over x. So my y is 8 and my x is 5. My y is 16, my x is 10. It's that easy, class. It is really that easy. They give you everything, okay? Let's keep it moving. Let's go to example 2. Example 2, solve problems using an equation. 1 inch equals 2.54 centimeters, okay? How many centimeters long is an 18-inch ruler? All right? So each inch will be 2.54 centimeters. That is a dead ringer for K. So K is going to be 2.54. And how many centimeters long is an 18-inch ruler? So we have 18-inch ruler. That's going to be our X, 18. So now we don't know what Y is. But good thing we know the equation would be Y equals KX. So let's fill that out. Y equals 2.54 times 18. And then, like they say down here, it's going to be Y. It's going to be 45.72 centimeters. So each inch, that's the constant of proportionalities. For every inch, it's going to be that amount of centimeters. Okay? That's how we know that's K and the constant of proportionality. All right? Go ahead. Example 2, try it. Pause it now so you guys can work it out by yourself. All right. Hopefully it's all done. Hopefully you figured it out. But let's work it out together now. A florist sells a dozen roses for $35.40. She sells individual roses for the same unit cost. Write an equation to represent the relationship between the number of roses X and the total cost of the roses Y. How much would 18 roses cost? Okay, class, we need to find K first. Okay? And for those of you that think K is $35.40, you are incorrect because that is for a dozen roses. If you think a dozen, which is 12, is K, you are also mistaken. We need to find out how much it costs per each rose, okay? So K will be the cost per each rose. So we can do, to solve that, we do 12 divided by, or 35.40 divided by 12. Okay? I don't feel like doing all this, but I know the answer is 2.95. All right? So the K will be $2.95. That's how much each rose costs. So now I know the equation would be Y equals KX, where K equals $2.95. So this is the equation that they're asking for. All right? Write an equation to represent the relationship. Boom. That's my equation. Now they want to know how much would 18 roses cost. So 18 roses, 18 would be my X. So I get Y equals 2.95 times 18. So when I multiply that out, I'm going to get 5310. And I have to put the two decimals because it is money. It's talking about how much it would cost. So this is your second answer. Okay? Write an equation. How much would 18 roses cost? I knew you guys would get it. You're so smart. Example 3. This is probably the easiest one. Example 3, determine whether y equals kx describes a proportional relationship. Can you represent the total cost y for admission and x rides at the amusement park using an equation in the form y equals kx? Explain. Make a table that shows the total cost. So, uh, so admission is $20 and each ride is $5. So you have to pay $20 to get in, plus $5 for one ride, $20 to get in, plus $10 for two rides, and then $15 for three rides, plus the $20 to get in. So since this did not start at zero, it is automatically not going to be proportional because for it to be a proportion, it has to run through zero. But let's look at this. We do 25 divided by 1 to get 25. We do 30 divided by 2 to get 15. And then we do 35 divided by 3, and that'll give us 1167. So for this table, our k is three different things. These are not equal ratios. Okay? These are not equivalent ratios. Therefore, it is not proportional. It will not work. They are not equivalent ratios, therefore it cannot be proportional. All right. Example 3, try it. Go ahead, pause it. All right. All right, all right, all right, all right, all right, all right. Okay, now ladies. Yeah. Okay. Determine whether we already went over that. Try it. Balloon A is released 5 feet above the ground. Balloon B is released at ground level. Both balloons rise at a constant rate. Which situation can you represent using an equation of the form y equals kx? Explain. Okay, balloon A, I get 9 over 1 equals 9. I get 13 over 2 equals 6.5. I get 17 over 3 equals 5 and 2/3. 5 and 2/3 ish. 5.6, whatever. Well, close enough. I'm close enough. You can believe me. So I do, for this one, I get 4 over 1, 4. I get 8 over 2, I get 4. I get 12 over 3, I get 4. Does anybody see what I'm getting at? Okay? Balloon B is the one that can be represented using an equation because 4 is my k, therefore I can get y equals 4x, and that is my equation. That is balloon B. It would not work for balloon A. Okay. So, that being said, you guys can get to your homework. Good luck. Here's the key concept for the whole entire lesson. And that's the end of the video. Hope you enjoyed it. And remember, if you're watching this video, you're a part of the class. See you next video, everybody.